Okay, Ohm's law, parallel circuits, Ohm's law, Watt's law, these still remain the same. Still, you're going to use that one to find your current. The significant change is adding the resistors in parallel. So this will be your formula. RT equals 1 over R1 plus 1 over R2 plus 1 over R3. And if you had more, you would just keep doing that exact same procedure. The three rules that we're going to add the resistor, solving for Ohm's law. The voltage is going to be constant in the parallel circuit. The current is actually going to add together. And then when you're adding the resistors in parallel, you want to apply that formula right here. Now, some people say, well, Mario, why do I got to do all of the steps? Like we said, then you have something to compare to. If you don't, because we know that these are all in parallel, that 120 is going to be at every one of those boxes. Then E divided by R equals I, P equals I times E. We got it all done. But how can we check our work? So what I like to do, work all the way to the end, find my totals, work my way backwards, and then check my work. That way you know that you've got everything done appropriately. So to simplify it, we have to do this formula first. Start by redrawing my circuit. It has 120 volts supplied to it. And I know I'm only going to have one resistor because I'm simplifying it. I'm going to do this formula right here. So 1 over 60 plus 1 over 30 plus 1 over 70 equals my RT. So I'm using this inexpensive calculator, so I'm going to have to do a little rounding. 1 divided by 60 equals 0.017. 1, and that's rounded. 1 divided by 30 equals 0.033. And 1 divided by 70 equals 0.014. I'm going to add up all of those values. 0.017 plus 0.033 plus 0.014 equals 0.064. 1 divided by 0.064, 1 divided by 0.064 equals 15.625. 15.625. What is that? That's my resistance total of the circuit. And then the cliff notes was, when you're adding resistors in parallel, it's going to be smaller than the smallest resistor. So if when you added this together, you came up with 35, then you know you messed something up. It's going to be smaller than the smallest resistor. E, I, P. I'm going to do all my totals here so we have something to check. 120 supplied to the circuit, 120 is going to be used in the circuit. To find the I, E divided by R equals I, so 120 divided by 15.625 and we end up with 7.68. I'm going to add the 0 because I like to keep my space saver in there. That way everything, you see everything to the 1,000. And I'm going to do the same thing right here. I'm going to take P equals I times E, 7.680 times 120. $921.6. So as we simplified this circuit, we know that combined you're going to have a resistance total of 15.625 ohms, a source voltage of 120 volts. There will be a total of 7.680 amps of current flowing through my circuit. and a total wattage of 921.6 watts in total. Now, working our way backwards, this is a parallel circuit. Voltage is constant in a parallel circuit. So right here we add the 120 to all of my missing voltage variables. And then now you're simply solving and applying the formulas. So E divided by R equals I. So 120 over 60 equals 2. So that one has 2 amps of current. P equals I times E. 2 times 120 equals 240. So we have 60 ohms of resistance, 120 volts at that resistor, 2 amps of current flowing through that branch, and 240 watts of energy. Yes, sir?
What did you do to get the P again?
P equals I times E. Current times voltage equals wattage. No problem. Same thing here. E divided by R equals I. 120 divided by 30, 4. And P equals I times Z. 4 times 120, 480. And then now, you just solve for the last one and we can start checking all of our work. To find I, E divided by R equals I. 120 divided by 70. 1.714. And P equals I times Z. 1.714 times 120. And we end up with 205.68. Now that you've solved for all of your variables, now it's time to check the work. We can't check the voltage because it's constant through all of those, right? But we can check the amps because we know that the current adds up in a parallel circuit. So we take 2 plus 4 plus 1.714. 2 plus 4 plus 1.714 equals 7.714 amps. Put an I so we keep it the same. Compare it to the total, 7.680. Very close. And then we do the same thing with our wattage. 240 plus 480 plus 205.68 equals 925.68. We said 921.6. That's very close. You're talking only 4 out of 925. So as you look at it, what are we thinking question-wise, formula-wise, or step-wise that remain to solve a parallel circuit? Yes, sir.
We should do the last part first, the parallel circuits.
I get all the way to the end to find my totals first. That way, when you solve everything, you have something you can check your work to. So if I had a current value, and let's say I ended up when I made a mistake and I put 20 amps of current, I go, okay, 20 plus 4 plus 1. Oh man, I'm way off when I check it to my totals. Then that way it gives me somewhere to go back and look. So that's why I like to make sure I have a set of numbers that I can check my work with. And then just like if you're working in the field, you do the math theoretically, then you bust out your meter, and then you would go take that reading with your electric meter. That way you're making sure what it says, what you know to be factually true, you're verifying with that meter that that's what's happening. So if this was your conductor on that circuit, you could put your clamp around meter on that conductor and you know that it should have 2 amps of current flowing through there. So that's the reason I make sure to get all the way to my totals, and then I just work my way backwards. So more questions or thoughts or?
I was trying to figure out your 1/1.1/60 times 130.
So on my little inexpensive calculator, I don't have none of the inverse functions. This is basically a 10 key. So I just take 1 divided by 60 and I turn it into the decimal. And then I add up all of my decimals to get the total value. And then you still take 1 over that decimal value to get your total right here. If you've got the TI-30X at Texas Instruments, it actually has that little inverse function on the calculator. But this one doesn't have nothing too special, but it's got big keys, so it's easy to use. So I just convert it to the decimals, get it to the end, add them together, put the 1 over, then you can figure it out. And what I want you to be proficient, you go, oh, 0.625, oh, that's 5/8. Just to start to memorize what those decimal equivalent of values are, so it makes it a little bit easier for you. So last thoughts before we push stop on this one.
This one seems much simpler than the first.
Easier than series?
Yeah, kind of crazy, but.
These aren't, as long as you know the rules for series and parallel, once you do a combination, there's no new rules. You just have to use the appropriate rule that you're going to be solving for. So it will get a little bit harder when we do the combinations. The formulas don't change. It's going to be your interpretation of how the circuit's drawn. And that's what's going to make it a little bit more challenging. No new rules, nothing, no new formulas. You just got to make sure you're making an educated decision as you're solving for them. Okay, I'm going to stop this one then.